So we looked at why the area underneath a velocity time graph is the distance. So we looked at this basic example and showed you how in this case is clearly clearly the area underneath the graph, because distance is equal to speed times time, and in this case the rectangle for when it's constant velocity is just going to be the speed or the velocity times the time. But what about for the other cases? In the other cases, they're not rectangles and the velocity is not constant. But there's still the same thing applies. We can still use the area underneath the graph. Now, so we now need to know how to calculate the area of these other shapes, which are usually triangles. Now, it depends how accurate you want to be, but I'll show you how to do it super accurately, and then we can look at how we can do it just by estimating, because the question actually says to estimate. So we can say here that this is a triangle, isn't it? Now a triangle, the area of a triangle is equal to half. Let's use a different. In fact, I'm going to pause this and we'll look at this in a bit more detail. So I've got just the graph on its own, much larger, and we're going to try to chop it up into shapes that we can calculate the area of. The area of a triangle is half the base times the height. So if we take this first triangle, and we're just going to pretend, to make it a bit easier, that this doesn't say minutes. We're going to pretend it says seconds. And obviously, if it did say minutes, we would need to take that into account. But for now, we're just going to say, just so you can understand this a little bit without adding a complication. So the height of this triangle, this one here, is 10. And the height is 2, and the base is 10. So the area of this triangle is going to be is half. Whoops. Let's try that out. Is equal to half the base times the height, which is equal to. So we can say half times 10 times 2. So that's going to be 5 times 2, which is 10. So that means that the distance travelled in this first part of the triangle is 10 meters. Now, what we can do after this point, and this is again just how to do it really, really precisely, is we could take this bit here and this bit here. So we've calculated A, and this would be B. Okay, and then we could take this triangle here, and we can call that C. And then we could take this rectangle here. In fact, we can go all the way. I would go all the way down to take this shape here. That would be D. And now with the rectangles, you just do base times height. So that's going to be 20 times 6. And then, so you can see what I'm doing here. I'm just chopping it into rectangles and triangles. So that's going to be E. I'll just pause the video and do the rest of them. So we then see all these different areas of the different triangles and rectangles, and we simply add them all up. And it doesn't matter how you chop it up, as long as you do it precisely. Now, if you wanted to make it an estimation to make it nearly right, then we could just take this whole thing here, and we could make that one triangle. Now you can see it's not going to be exactly right, because you're going to have this bit as well here, and you could take that as a triangle like that. But that's how you do it as an estimation. Okay, all right. I'll just stop the video there.